Welcome everyone to this interesting question. Given to us is a square and sharing one common vertex we have a second square. The distance between these two vertex is given as 5 centimeter. Using only this data we have to find what is the distance between the other two vertex, or we have to find the value of x. We'll solve the question by two approaches. First approach is a logical approach. Here in this question there is nothing given about the size of the brown square. So we can have this square as slightly large or small, but the question remains unchanged till we have got this distance between vertices as 5 and this other vertex we have to find. So let's decrease the size of this brown square. Now here we have reduced the size of brown square, but the question still remains unchanged because the distance between these vertices is 5 and distance between other two vertices is what we have to find. Now here we have reduced the size further, but still the question remains unchanged and thus our answer for value of x will remain unchanged. What if we'll reduce this size of the square further and further till it becomes a point square? Here our square has become a point square, so the distance between this vertex, that 5, becomes the side length of the green square, and the distance between the other two vertex becomes the diagonal of the green square. And we know that the diagonal length of the square is root 2 times of side, so x is equals to 5 root 2 centimeter. I'm sure you must have enjoyed this logical approach, which is quite useful when we are doing multiple choice questions. Let's see the second approach, which is more of theoretical approach. So for that, let's do some construction and form a parallelogram A, E, F and H. As this is a parallelogram, so opposite sides are equal. So FH will be nothing but 5 centimeter. And these opposite angles will be equal. So this angle E will be equals to angle H. Its use we'll see later on. So further we'll join BH. And here we'll try to prove that triangle AEBH and triangle DAE, these two triangles are congruent. So let's check on this. AH and EF, they are equal because they are sides of parallelogram, and EF and DE, they are equal because these are sides of square. AB and DA, they are the sides of squares, so AB is equals to DA. Now these two sides are equal, so if we can prove that these inclusive angles are also equal, then by SCS the triangles will be congruent. So for that I am extending DE to meet AH. Now this angle is 90, the lines are parallel, and thus corresponding angles, this angle will also be 90 degrees. Now here if this angle here is alpha, so in triangle DA and this particular point, this angle will be 90 minus alpha, and thus this blue angle, that will be alpha. So by SAS we can say that triangle DEA, that's triangle DEA, this is congruent to triangle AHB. Now as the triangles are congruent, thus the corresponding sides will be equal. AE and BH will be equal, or we can say BH is 5 centimeter. So also if we'll see the corresponding angle, so this angle E, this will be equals to angle H. Now here angle around the point if we'll see, then we can make out that angle H is nothing but 90 degrees. Let's check this triangle HBF. So this triangle is a right angle triangle, two sides are given, we can find the length of hypotenuse, which is 5 root 2 centimeter. If you enjoyed the video, do press the like button, and if you are new to the channel, do subscribe it. I'll see you in next video. Till then, tata, bye bye.